trucks and buses that will transform tomorrow. The rumble of diesel engines has dominated our highways and city streets for over a century, but a silent revolution is brewing in the world of commercial transportation. While the automotive industry races toward an electrified future, it's not just sleek sports cars leading the charge. It's the giants, the workhorses, the massive machines that keep our world moving. From hydrogen-powered semi-trucks to autonomous city buses, the future of commercial transportation is arriving faster than anyone imagined. Vehicle 10, Mercedes-Benz Gen H2 truck, the Hydrogen Titan. Deep in the research facilities of Mercedes-Benz, engineers have been perfecting what could be the ultimate solution to long-haul trucking's environmental challenges. The Gen H2 truck represents Daimler's most ambitious project yet, a complete reimagining of what a freight hauler can be. This isn't simply an electric truck with a different power source, it's a fundamental shift in how we think about zero-emission heavy transportation. The heart of the Gen H2 lies in its revolutionary dual-motor setup, with each motor producing 230 kilowatts. A combined torque output is staggering, over 2,071 newton-meters per axle, translating to more than 1,500 foot-pounds of pulling power at each wheel. This immense torque delivery means the Gen H2 can handle any load that a traditional diesel truck can manage without the compromise that many feared would come with alternative fuel technologies.
The real breakthrough isn't just in power, it's in range and refueling efficiency. The Gen H2 utilizes liquid hydrogen storage, a technology that allows for incredible energy density. The truck can travel between 600 to 1,000 kilometers on a single fill-up, achieving nearly 620 miles of range while maintaining a full 25-ton payload capacity. Perhaps most remarkably, the entire refilling process takes less than 50 minutes, matching the convenience of diesel while delivering zero emissions. The engineering challenges overcome in creating the Gen H2 are immense. Liquid hydrogen must be stored at temperatures of -253 degrees Celsius, requiring sophisticated insulation and safety systems. The fuel stacks must convert hydrogen and oxygen into electricity with remarkable efficiency, while the electric motors must deliver consistent power across varying loads and conditions. The result is a truck doesn't roar across continents, it whispers, carrying its cargo with the quiet confidence of advanced technology. Vehicle 9, Tesla Semi, the electric freight revolutionary. When Tesla announced their entry into the commercial trucking market, skeptics questioned whether the company known for luxury electric cars could tackle the demands of heavy freight hauling. The Tesla Semi proved them wrong with a combination of brutal acceleration, impressive range, and the kind of technological sophistication that has become Tesla's hallmark.
The Semi's powertrain represents a masterclass in electric vehicle engineering. 3 electric motors work in harmony to produce over 1,000 horsepower, with torque delivery reaching approximately 1,050 foot-pounds. But raw power numbers only tell part of the story. When fully loaded at the legal maximum of 80,000 pounds, the Tesla Semi can accelerate from 0 to 60 miles per hour in just 20 seconds, a performance that would shame many passenger cars and leave diesel trucks struggling to keep up. Tesla offers the Semi in 2 configurations, providing either 300 or 500 miles of range depending on customer needs. The shorter-range version serves regional delivery routes, while the long-range model tackles serious long-haul responsibilities. Supporting this range is Tesla's network of megachargers, capable of delivering up to 1 megawatt of charging power. This means that while drivers take their mandatory rest breaks, the Semi can add hundreds of miles of range to its battery pack. The aerodynamic efficiency of the Tesla Semi is perhaps its most impressive achievement. The truck's drag coefficient is lower than that of a Bugatti Chiron, a feat that seemed impossible for such a large vehicle. Combined with regenerative braking that recovers energy during deceleration, the Semi achieves efficiency levels that make traditional diesel trucks look primitive by comparison. The price point, between $150,000 and $200,000 depending on configuration, represents not just a purchase but an investment in operational efficiency, reduced fuel cost, and environmental responsibility.
Nikola Tre BEV and FCFV, the sustainability specialist. The Nikola Corporation's journey has been marked by controversy and redemption, but the Tre series represents the company's commitment to proving their technology in the real world. Available in both battery electric and hydrogen fuel cell variants, the Tre showcases 2 different approaches to zero-emission trucking, each optimized for specific use cases. The battery electric variant of the Tre is designed for short-haul logistics operations, offering up to 500 kilometers of electric range. This makes it ideal for urban delivery routes and regional distribution networks where daily mileage is predictable and charging infrastructure is readily available. The electric motors provide instant torque delivery, making the Tre BEV particularly effective in stop-and-go traffic conditions that would challenge traditional diesel engines. The hydrogen fuel cell variant extends the Tre's capabilities into mid-range hauling applications. By combining hydrogen fuel cell technology with high-torque electric motors, the FCFV model bridges the gap between short-haul electric trucks and long-haul diesel vehicles. The hydrogen system provides the energy density needed for longer routes, while maintaining the environmental benefits of zero-emission operation. Inside the truss cab, technology takes center stage. Wide digital displays provide drivers with comprehensive vehicle information, while advanced telematics systems monitor everything from energy consumption to route optimization. The track is designed with autonomous readiness in mind, featuring the sensors and computing power needed for future self-driving capabilities. This isn't just a truck, it's a mobile smart terminal that happens to haul cargo.
Vehicle 7, Volvo Vera, the invisible hauler. The Volvo Vera challenges every assumption about what a truck should look like and how it should operate. By completely eliminating the driver's cab, Volvo has created something that looks more like a futuristic cargo pod than a traditional truck. This isn't just a design experiment, it's a fundamental reimagining of logistics and transportation. The Vera operates as part of a fully autonomous ecosystem designed specifically for moving containers between ports and logistics hubs without human intervention. Its low-slung profile and electric propulsion system make it nearly invisible as it glides through industrial environments. The powertrain specifications are closely guarded by Volvo, but the company's focus is clearly on precision and efficiency rather than raw power. What makes the Vera truly revolutionary is its integration with intelligent logistics systems. The truck doesn't just move cargo, it communicates with warehouse management systems, traffic control infrastructure, and other autonomous vehicles to optimize routes, timing, and efficiency. GPS coordinates, LiDAR sensors, and advanced computing systems replace the human driver, creating a transportation solution that operates 24 hours a day without rest breaks, sick days, or human error. The Vera represents Volvo's bet on a future where logistics becomes invisible, where goods move seamlessly through supply chains without the complexity and cost of human oversight. It's a glimpse into a world where transportation becomes as automated and reliable as other industrial processes, fundamentally changing how we think about moving goods from point A to point B.
Vehicle 6, Scania AXL, the autonomous earth mover. While most autonomous vehicle development focuses on highway and urban environments, Scania took a different approach with the AXL concept truck. Designed for mining operations and off-road industrial work, the AXL operates in some of the harshest environments on Earth, places where traditional trucks struggle and human drivers face constant danger. The AXL is powered by renewable biofuel engines, providing the torque and reliability needed for heavy-duty mining operations while maintaining environmental responsibility. Though Scania keeps specific torque figures confidential, the truck is engineered to handle massive payloads across terrain that would challenge any conventional vehicle. Dust, rock, extreme temperatures, and unstable surfaces are all part of the AXL's daily operating environment. The truck's industrial armor and sensor arrays give it an appearance more suited to lunar exploration than earthbound mining. Multiple cameras, LiDAR systems, and radar units provide 360-degree environmental awareness, while artificial intelligence systems navigate complex terrain and avoid obstacles. The AXL doesn't just replace human drivers, it eliminates the need for humans to work in dangerous mining environments. The implications of the AXL extend far beyond mining. If autonomous trucks can operate reliably in the chaotic environment of the mining side, they can certainly handle more predictable applications like highway freight and urban delivery. The AXL serves as a proving ground for autonomous technology, pushing the boundaries of what's possible in industrial automation.
Vehicle 5, Hyundai HDC6 Neptune, the artistic hauler. When Hyundai unveiled the HDC6 Neptune concept, it proved that functional doesn't have to mean boring. The Neptune combines the streamlined elegance of Art Deco trains with the advanced technology of hydrogen fuel cells, creating perhaps the most visually striking truck design ever conceived. The Neptune's estimated power output exceeds 400 kilowatts, providing more than enough capability for major freight hauling while producing zero emissions. The hydrogen fuel cell system represents Hyundai's commitment to clean transportation technology, building on their experience with passenger fuel cell vehicles like the Nexo SUV. But it's the design that truly sets the Neptune apart. The truck's wraparound windows create an almost aircraft-like cockpit environment, while the aerodynamically optimized grille and body panels hidden at the advanced engineering underneath. Every line and curve serves both aesthetic and functional purposes, reducing drag while creating a vehicle that looks like it belongs in a science fiction film. While final pricing and detailed specifications remain confidential, the Neptune signals Hyundai's serious intention to compete in the commercial vehicle market. This isn't just about building another truck, it's about leading the transformation of an entire industry through superior design and technology. Vehicle 4. Arrival Electric Bus, the modular city cruiser. The Arrival Electric Bus represents a completely different approach to public transportation manufacturing. Rather than adapting existing bus designs for electric propulsion, Arrival started from scratch, creating a modular, lightweight vehicle that challenges every assumption about what a city bus should be. The bus's composite body construction makes it significantly lighter than traditional steel-framed buses, improving efficiency and reducing wear on city streets. The 250-300 kilowatt-hour battery pack provides up to 250 miles of range, more than enough for most urban routes, while offering the flexibility to handle longer suburban services. Inside, the Arrival bus prioritizes passenger experience with panoramic windows, a flat floor design, and an open space layout that accommodates standing passengers, seated riders, and accessibility equipment with equal ease. The interior feels more like a modern subway car than a traditional bus, with clean lines and abundant natural light. At approximately $350,000, the Arrival bus represents a premium approach to public transportation. Cities investing in these vehicles aren't just buying buses, they're making a statement about their commitment to sustainable, passenger-focused public transit. The modular design also allows for customization and upgrades, ensuring that the buses can evolve with changing urban needs.
Vehicle 3, BYD K9 Electric Bus, the global workhorse. While other manufacturers focused on concept vehicles and future technologies, Chinese company BYD took a different approach. They built electric buses and put them into service around the world. The K9 electric bus is already operating in cities from London to Los Angeles, proving that electric public transportation isn't just a future possibility, but a present reality. The K9's 324 kilowatt-hour battery pack provides up to 155 miles of range with fast charging capability that allows for quick top-ups during route breaks. Dual motors and regenerative braking systems maximize efficiency while providing the acceleration and hill climbing ability needed for urban service. What makes the K9 particularly impressive is its affordability. Starting at around $250,000, it costs significantly less than many competitors, while offering proven reliability and performance. This price point has made electric bus adoption economically viable for cities that previously couldn't justify the higher cost of alternative fuel vehicles. The K9's success isn't just measured in units sold, it's measured in the millions of passengers who now ride electric buses instead of diesel vehicles, in the reduced air pollution in urban centers, and in the proof that electric public transportation can be both practical and profitable.
Vehicle 2, Toyota e-Pallet, the shapeshifter. The Toyota e-Pallet defies categorization because it's designed to be whatever its users need it to be. This fully autonomous modular pod can transform from a mobile office to a medical clinic to a retail store, all while providing efficient electric transportation. The e-Pallet's 150 to 200-mile range is optimized for continuous fleet use in urban environments and smart campuses. Rather than focusing on maximum range, Toyota prioritized the flexibility and modularity that make the e-Pallet uniquely versatile. The vehicle can be reconfigured for different applications throughout the day, serving as a delivery van during morning hours and a passenger shuttle in the evening. The pricing structure reflects this modularity, with costs starting around $200,000 and varying based on configuration and intended use. Cities and companies aren't just buying a vehicle, they're investing in a transportation platform that can adapt to changing needs and applications. The e-Pallet represents Toyota's vision of mobility as a service rather than vehicle ownership. Instead of buying specific vehicles for specific purposes, organizations can deploy e-Pallets that adapt to whatever transportation challenge they face. Vehicle 1, Mercedes-Benz Future Bus, the intelligent navigator. At the pinnacle of advanced public transportation since the Mercedes-Benz Future Bus, a semi-autonomous electric marvel that represents the ultimate fusion of artificial intelligence, electric propulsion, and passenger comfort. This isn't just a bus, it's a rolling demonstration of what public transportation can become when technology serves both efficiency and human needs.
The Future Bus's City Pilot technology represents one of the most advanced autonomous driving systems ever deployed in public transportation. Radar, LiDAR, GPS, and vehicle-to-everything communications create a comprehensive understanding of the urban environment that surpasses human perception. The bus doesn't just follow a route, it actively monitors traffic patterns, pedestrian movements, and road conditions to optimize its journey. Power comes from electric motors producing over 250 kilowatts, supported by regenerative braking that recovers energy during the frequent stops typical of urban bus service. Smart grid capability allows the bus to serve as a mobile energy storage unit, potentially feed power back to the electrical grid during peak demand periods. The passenger experience in the Future Bus is unlike anything in traditional public transportation. Lounge-like interiors with premium seating, LED lighting systems that adjust automatically based on time of day and weather conditions, and climate control that adapts to passenger load create an environment more reminiscent of a high-end hotel lobby than a city bus. The expected cost of over $400,000 reflects the advanced technology and premium materials used throughout the Future Bus. Cities investing in these vehicles aren't just buying transportation, they're making a statement about their commitment to providing world-class public transit that rivals private vehicle ownership in comfort and convenience.
The road ahead, transportation transformed. These 10 vehicles represent more than just technological advancement. They embody a fundamental transformation in how we think about moving people and goods. From the hydrogen-powered Mercedes-Benz Gen H2 that can haul 25 tons across continents without emissions, to the modular Toyota e-Pallet that adapts to whatever transportation challenge it faces. Each vehicle solves different pieces of the transportation puzzle. The shift toward electric and hydrogen propulsion isn't just about environmental responsibility. It's about operational efficiency, reduced maintenance costs, and the quiet operation that makes these vehicles better neighbors in urban environments. The integration of autonomous technology doesn't just reduce labor costs. It enables 24-hour operation, eliminates human error, and creates transportation systems that can adapt to changing conditions in real time. Perhaps most importantly, these vehicles represent a shift from transportation as a necessary evil to transportation as a positive experience. The Mercedes-Benz Future Bus transforms the daily commute into a comfortable, productive journey. The Arrival electric bus makes public transportation something passengers choose rather than endure. The Tesla Semi makes freight hauling efficient and environmentally responsible.
The commercial transportation industry stands at a crossroads. The vehicles featured here aren't just prototypes or concept cars. They're production-ready solutions that are already beginning to transform how goods move and help people travel. From the mining sites where Scania AXL trucks operate autonomously, to the city streets where BYD K9 buses carry passengers silently through urban senates, the future of transportation is already here. The question isn't whether these technologies will succeed, it's how quickly they'll become the new normal. As cities grapple with air pollution, logistics companies seek operational efficiencies, and consumers demand sustainable transportation options, these vehicles provide answers that were unimaginable just a decade ago. The revolution in commercial transportation is happening now, and these 10 vehicles are leading the charge. They don't just transport, they transform, carrying us toward a future where moving people and goods is cleaner, quieter, smarter, and more efficient than ever before. The road ahead has never looked more promising.